Okay, in this video we're going to be looking at triangles. The triangle is a polygon with 3 sides and 3 angles. And polygons are very rigid and strong shapes. And this means that it's used a lot in construction and buildings. If you have a look at buildings or bridges and things like that, you'll notice that there's a lot of triangles in them. And it is one of the most commonly used shapes in design and in construction. So if we know the properties of triangles, we're able to use them when we're thinking about design. And we can also use them to help us understand more complex shapes. So the first thing on your page on the left-hand side is a diagram that says how many triangles do you see? And this is just a little bit for fun to see how you can think about this, but I want you to have a go at looking at how many triangles you see in that diagram. Next thing I want you to do is to draw a triangle in the space and on the left-hand side, and I want you to measure all 3 angles using a protractor. Then I want you to add all of the angles together and work out the sum of the angles. So you can stop the video now and try these activities. Okay, so hopefully you've worked out the sum of your angles in a triangle, and hopefully you got that was 180 degrees, and that might have been something that you already knew from previous year's geometry. Okay, we're going to look at all the different types of triangles that we have. The first one, the purple one here, is we've got a triangle where all of the 3 sides are equal and all 3 angles are equal. And if all 3 angles are equal, we've got 180 degrees for the total sum of angles in this triangle. If we divide that by 3, that means each angle is 60 degrees. So that angle is 60 degrees, as is that angle, as is that angle. And that is called an equilateral triangle. Okay, so all 3 sides and all 3 angles are equal. In the second triangle here, we've got no sides and no angles equal to each other. And if we have that, in that case, it's called a scalene triangle. So no sides or no angles are equal to each other. In the green one here, we've got these 2 sides equal to each other. And you'll know that they're equal to each other in your work because they'll be marked with a line like that, okay? And if those 2 lines are equal to each other, then by definition the 2 angles at the bottom of those 2 lines will also be equal to each other, and that's called an isosceles triangle. Okay, the next 3 triangles are named by the angles that are in them. So in this blue one here, if we have a triangle with 1 right angle, it's called a right angle triangle. And if we have a triangle where all 3 of the angles are acute, so all 3 angles are less than 90 degrees, then that is called an acute triangle. And if we have a triangle where one of the angles is obtuse, so one angle is greater than 90 degrees, then we have an obtuse triangle. Okay, next thing we're going to look at is the exterior angle theorem, and this is talking about looking at the angles that are outside the triangle. So do you see if we extend one of the lines of the triangle, and you could do this with all 3 of the lines, but if we just look at this one here, if we extend it, then that makes an angle with one of the sides of the triangle that is outside, so exterior to the triangle. So we'll call that E for exterior. The theorem is that the exterior angle is equal to, so the size of it is equal to the sum of the 2 angles opposite it. So if we call these 2 angles, oops, sorry, my writing is a bit messy there. Try that again. So if we call that angle X and that angle Y, the exterior angle is equal to the sum of those 2 angles. And I want you to see if you can explain, either using algebra or just using words, why this theorem works the way it does. And I'll give you a bit of a hint. You need to think about using the fact that angles in a triangle sum to 180 degrees and angles on a line also sum to 180 degrees. And we'll take a look in class at what everybody came up with. Okay, last thing we're going to do is we're going to look at some problems where we've got to work out the sizes of angles in a triangle. So in this first purple one here, we've got a triangle with with two angles that we know, 62 degrees and 83 degrees, and one angle that we don't know. So we need to use the fact that all three of these angles, so 62 plus 83 plus A, must equal 180 degrees. Okay, and I'll just put my degree sign in here. So to work out A, what we would do is we can add the other two angles together. So we get 145 degrees altogether on this side, plus A equals 180 degrees. And to work out A, we're going to subtract 145 from 180. And that gives us A equals 35 degrees. Okay? Now in this second triangle, we need to think about the fact that we have an isosceles triangle. And we know we have an isosceles triangle because it'll be marked. So we know that this side and this side are equal to each other. Therefore, that angle there, A, is equal to this angle here. So we can call that A as well because they're the same. Those two angles are equal. Okay, so what we've got here now is we've got two angles we don't know, but they're equal. So A plus 28 has to equal 180 degrees. So if we collect like terms, we actually have 2A plus 28 equals 180 degrees. And if I subtract 28 from both sides, so just using a bit of my algebra, solving equations, I get 2A is equal to 152 degrees. So if I divide now both sides by 2, I get A is equal to 76 degrees. Okay, so that means that each of those angles would be 76 degrees each. Okay, so that's our lesson on triangles. You can go ahead and try some of the classwork in class now.